Functional response is a very important tool to use for ecologists. Functional response is used to demonstrate the relationship between the density of the prey population compared to the number of prey consumed by the predators. This model may seem very simple, but due to the varying characteristics of different prey and predators, there is fluctuation in the predation rates. This is why there are three types of functional responses in order to account for these variations. The first functional response is a linear graph. This shows that as the rate of prey consumption increases, so does the prey's population density in a linear form. Type 1 is also used when a predator consumes a constant proportion of prey until the predator is satisfied. This then causes the predator to consume a consistently smaller proportion of the population. This is demonstrated as the purple line in the graph. This is predominantly found in more passive predators. One example of this is the spider, who waits for the food to be caught in its web instead of seeking the prey out. This is why type 1 functional response is based on the assumption that a predator may encounter its prey within a fixed time. This is also most ideal for small prey densities because they are not being consumed faster than they are able to repopulate. Instead, it is an equal proportion which causes the linear trend on the graph. This can also be represented using the equation on the screen. Y equals ATSX, where Y represents the prey consumed by the predator, X is density of one prey, TS is representative of the predator's availability to hunt, and A is a constant known as the discovery rate. Type 2 functional response represents the middle ground between types 1 and 3. This is seen when the number of prey consumed begins to slow down as the prey population density increases. This can be seen in the plateau of the curve that is demonstrated on the graph in the orange color. This can also be seen in the equation shown on the table. Y equals A TTX over 1 plus ABX, where TT would cause a decrease in the number of prey present. This is due to the prey being eaten slower. This plateau occurs because the predator consumes larger quantities of the prey and therefore delegates more time to handling the prey instead of the consumption of the prey. This is why the declining rate of a prey consumption causes a decline in the proportion of the prey consumed by the predator. Handling is essential in the type 2 functional response. This is because the prey is eaten more slowly due to the decrease in the number of prey present. One example of the 2 functional response is that small mammals destroy most of the gypsy moth pupa in sparse populations of the gypsy moth, but in high-density defoliating population small mammals kill a negligible proportion of the pupa. The final most complex response is the type 3 response. A situation can be classified as a type 3 response when the prey density increases. There is an instant increase in the proportion of the prey consumed. Due to the predator handling the prey for more time before the predator is satisfied, this causes the proportion to decrease. This can be demonstrated in the green curve on the graph, which looks similar to an S curve on the left side. This can also be seen using the equation given for the type 3 response, which is Y equals ATT XK over 1 plus AB XK. When looking at A in this situation, it is no longer constant and should also increase in correlation to the number of prey present. One example of a type 3 functional response is birds, which are able to switch to the most abundant population species by being able to recognize that species visually. This causes the mortality to first increase with the prey, increasing density, and then it declines. Two things that are large factors in classifying which functional response a predator-prey relationship is based on is search efficiency and handling times. For type 1, that is based on the assumption that the predator encounters a prey within a fixed time. For type 2, this is a decrease in the prey present, meaning the prey are eaten more slowly. This is then the most common functional response, when the search rate is considered to be constant. Type 3 is the most complex functional response because it includes and considers behavioral pattern of predators. When a predator is able to understand and learn a behavior, this causes an increase in the discovery rate. It is hypothesized that the temperature and body mass affect the predation rate. Considering the experiments done using killer flies, which is the image on the right, in relation to fruit flies, when the temperature increased, the killer fly's predation activity also increased. This can be related to a type 1 functional curve because when looking at evidence from the herbivores as well as carnivores, which is shown in the graph to the right, it is shown that as the temperature increases, this allows the handling time to become more of a linear trend when looking at the curves of the functional response types. This is why, as the temperature is increased, the functional response curve is shifted towards that of a type 1 curve, which can be seen in the graphs to the right. Another thing that affects the type of functional response is body mass. A larger predator that consumes smaller prey have a lower handling time. A larger body mass will lead to a larger abundance of the prey consumed, but the size of the prey is what determines the functional response. This also favors the type 1 functional curve. One example of this is moose. Because of the body mass ratio of moose to its prey, this causes a smaller handling time because it takes less time to consume the prey of the moose. Overall, our hypothesis was that temperature and body mass have an effect on the functional response of a predator. This hypothesis was able to be supported through the applied literature that was given. Thank you.